Hello students. Uh, today's second lecture of advanced structural analysis. This is for MTech structural engineering program. Today's topic is today will topic is types of indeterminacy, and basically we will be dealing with one of the type of indeterminacy, that is static indeterminacy, in this lecture. So let us proceed. Myself, Shabdanshu Jaiswal, Assistant Professor, Degree University, Lucknow. So basically, we start with various types of indeterminacy. We already know what is indeterminacy. Indeterminacy is a, number of equations exceeding the equilibrium condition is known as indeterminacy. Basically, indeterminacy is concerned with its two types. First is static, and the other one is kinematic. As the term suggests, static means something that is stationary, and kinematic means something that is in motion, or something that is concerned with motion or a movement. So basically, this is a basic understanding about two of them. Uh, we will be dealing specifically with the static indeterminacy in this lecture. So a static indeterminacy is basically we calculate static indeterminacy. It consists of two types. First is external and the other one is internal. In terms of calculating static indeterminacy, we need to calculate external static indeterminacy as well as internal static indeterminacy. So we can easily say that total static indeterminacy of a structure is equals to a degree of external static indeterminacy plus degree of internal static indeterminacy. So we move forward. This is what we can conclude about the static indeterminacy. Uh, Static indeterminacy is a equation in addition to static equilibrium equation necessary to completely analyze a static indeterminate structure. Basically, this is what a basic indeterminacy understanding static. That number of equations exceeding the equilibrium condition. For example, if we take example of a fixed beam. Uh, Fixed beam is having the both end fixed. At each fixed end, we are having three internal reaction. Total number of internal reaction in case of a fixed beam will be six. 6 minus 3. 3 is basically number of equilibrium equation if the beam is in 2D frame. Then the number of equations 6 minus 3 will be is equals to 3. So there are three extra equation that we need to completely analyze uh, this beam. So degree of static indeterminacy in case of a fixed beam will be 6. So similarly, this is the formula that we can see. Uh, ds is equals to DSE plus DSR. Basically, what is DS? DS is degree of a total degree of a static indeterminacy. DSE is total external static indeterminacy, and DSI is the total internal static indeterminacy. This is a basic approach about DS. DS is total number of knowns minus static equilibrium equation. Now, we calculate DSE. Please focus very give your full focus over here, because it is a confusing part of it for students. DSC is equals to R minus 6 if the frame is a space, and DSC will be equals to R minus 3 if the plane is if the frame is in plane. The DSC basically is degree of external static indeterminacy. R is the number of reaction, and 6 is the number of equilibrium condition. So for a space frame, I already told you the number of equilibrium equation will be 6, and for plane frame, the number of equilibrium equation will be 3. So in the previous lecture, we have seen the bifurcation of this count. So basically, DSC will be r minus 6 for a space frame and r minus 3 for plane frame. Now, if we talk about DSI, DSI is the degree of internal static indeterminacy. So DSI, if we talk about, it will be different for different kind of frames. Uh, we have already discussed this equation. This equation is nothing but the equation that says M is equals to 2J minus 3. If this equation satisfies, we have studied this in the previous lecture. If this equation satisfies, then the structure will be statically determinate, otherwise it will be an indeterminate structure. So basically what we'll do, we'll bring this M to this side, and that will give the difference between M and 2J minus 3, and that will be degree of static indeterminacy. So this equation is nothing but the equation that we have discussed in the previous lecture, that is needed to be satisfied in order to get a determinate structure. So when this M comes to this side, it will become M minus 2J minus 3, and this will give the difference of this will give the degree of static indeterminacy, or degree of static internal indeterminacy. So this will be M minus 2J minus 3. This equation will give the value of static internal indeterminacy for a pin jointed frame or a pin jointed plane frame. Then for a pin jointed space frame, the equation will become like M minus 3J minus 6. Similarly, we know 6 is the number of equilibrium condition. Then for a rigid jointed plane frame, the equation is nothing. See, one thing need to be understand that this is only the degree of internal static indeterminacy. The degree of external static indeterminacy will be calculated from using these two cases. For a plane frame, it will always be r minus 3, and for a space frame, it will always be r minus 6. So we are just calculating this part of equation. This part of equation will be calculated from here. So for a rigid jointed plane frame, it is 3C, and for a rigid jointed space frame, it will be 6C. Now this C term is introduced here. The C is a number of cuts required to obtain an open configuration of a structure, or we can simply say the C is a number of closed loops. We'll discuss it like this. If this is a rigid frame, if this is a if this is a rigid frame, then in this case the value of C will be 1, 2, 3, and 4, because C represents the number of closed loops. In this structure, in this frame, in this rigid jointed frame, the number of closed loops are 1, 2, 3, and 4. The value of C will be 4. Similarly, if we say a structure is like this, number of closed loops in this case is 1. So the value of C will become 1 in this case. So basically, this is how we can understand how to put the value of C in this equation. So quickly recall it. DS degree of static indeterminacy will be equals to degree of external static indeterminacy plus degree of internal static indeterminacy. Degree of external static indeterminacy is equals to r minus 3 for plane frame and r minus 6 for space frame. Similarly, degree of internal static indeterminacy for a pin jointed plane frame will be M minus 2J minus 3. Rigid pin jointed space frame will be M minus 3J minus 6. And for rigid jointed plane frame, it is 3C. For rigid jointed space frame, it is 6C. Now, using these equations and the basic understanding about how what is indeterminacy and how to calculate and what is we are calculating, we can easily calculate the further this in the upcoming lectures, upcoming slides. So basically, this is nothing but the general formula for this. Says ds total. It is a total thing. Um, uh, we can see. But if you have this formula in your mind, you don't need to remember this. This is a basic general formula for degree of static indeterminacy. That is ds is equals to m plus r minus 2j for pin joint and plane frame. M plus R minus 3J for pin jointed space frame, 3M plus R minus 3J for pin jointed plane frame, and 6M plus R minus 6J for rigid jointed space frame. Okay, so this RR, this we'll discuss in the upcoming slide. This RR is basically in case of internal hinge. So I would like to consider this as an example. It will be producing a better understanding about this concept. So uh, let us quickly move forward. Now, see, here we will discuss this concept of internal hinge. A hinge provided anywhere in the structure cannot transmit movement, a moment from one part of a structure, uh, thus provided an additional condition of equilibrium. See, what is internal hinge? Basically, a hinge, the role of hinge is to allow the movement. So, if the hinge is located anywhere inside the structure, it will simply allow one motion, or it will simply allow one displacement in term of a moment. So, if hinge is present, internal hinge is present, this is simply telling us that a movement is allowed on that part. So basically, that is somewhere giving an extra equilibrium equation. We are if we consider a plane frame, the number of equilibrium equation is 3. So basically, in case of internal hinge, if we are having internal hinge, one internal hinge, or impact of internal hinge is 1, then the number of reaction that is offered by internal hinge will be 1. So total number of reaction will become, and equilibrium condition will become 3 plus 1, that is 4. So this is something we'll discuss with an example in the upcoming slides. Now, what is internal link? Internal link is nothing but the at internal link, sorry, link. We have discussed in the previous lecture also that in case of internal link, only one reaction is there. So sigma m will be 0 and sigma h will be 0. Two additional equilibrium equations will be needed in this case if the internal link is provided. Link is basically something like two hinges in a single part. So at the both ends, that will allow a single moment. So that will give a external reaction, two external extra reactions. So quickly understand, if a pin joint plane frame, number of equilibrium equations are 2. For a pin joint space frame, number of equilibrium equation is 3. A rigid 3, spaces 6. Now, what is basically we sometimes we listen that the structure has become unstable. So, as a name suggests, as a term suggests, we can easily say the structure which is not stable, a structure whose stability is not confirmed, is termed as unstable structure. What is the condition of structure getting unstable? Basically, this equation is like n is, if the n is greater than r, where n is the number of equilibrium equations and r is the number of internal reactions. So, like, let us take an example over here. Uh, for example, this is a sorry, this is a propped cantilever beam. Here, the total number of internal reaction is 4. Number of equilibrium equation is 3. So it is indeterminate to a degree of 1. Now, similarly, here the number of the value of n will be 3. This is n. This is r. So in this case, n is greater than r. So this is not an unstable structure. This is an indeterminate structure to a degree of 1. But if we consider another example, like this is a roller, this is a beam carrying two roller supports. So we know this that on a roller support the number of internal reaction will be 1. Number of internal reaction will be 1 here. Total number of internal reaction will be, in this case, will be 2. 2 minus 3. 3 is the number of equilibrium equation, is equals to minus 1. Here this is R and this is N. Sorry, I need to correct this. This is not like this. As we can easily see, this is like this. Here R is greater than N. That is why it is an indeterminate structure to a degree of 1. But in this case, N is greater than R. So this is a case where we can say the structure is a unstable structure, and literally we can see that if you stand keep something on two roller supports, any external reaction will disturb its stability. So we can see clearly see this structure is unstable, and we have calculated by using this condition, then N is greater than R. So this structure is unstable. If one external reaction is allowed on the structure, then this will become stable. So if we remove this thing and convert it to a hinge support, then the reaction over here will become 2 and here will be 1. Total will be 3. 3 minus 3 will be 0. This will become a determinate structure, that is a stable structure. So this is a basic approach and understanding about what is a stability of a structure, what is an unstable structure, or how to calculate the determinate and indeterminate structure. Now, this is a basic definition we have already discussed about static indeterminacy. It says 2j minus 3 condition. Okay, it's fine. We have already discussed this thing in the previous slides. These are the basic examples of a statically indeterminate structures. This is a simply supported beam, a roller support. This is a hinge support. Total number of internal reaction over here is 3. 3 minus 3 is equals to 3. This is internally. This is a statically indeterminate determinate structure. This is also a statically determinate structure. Total number of reaction over here will be 3. Here it will be 0. Total number of reaction in this case will be 3. 3 minus 3. 3 is equilibrium condition, that is 0. So this is a determinate structure. Here also, due to external thing, it will be a determinate structure. And if we talk about internal also, 1, 2, 3, 4, 5, 6, 7. So M is 7 and 2j j is 1, 2, 3, 4, 5. So 10 minus 3, that is 7. So 7 minus 7 is equals to 7. It means this is an internally determinate structure also. Let me show you like this. We know for this stress we need to see whether it is internally and both externally determinate or not. Externally we can easily see number of reaction over here will be 2. Here it will be 1. Total, if we see calculate PSC, then it will be 3 minus 3, that is 0. Now if we talk about internal, we know this equation need to be satisfied, that is DSI for a pin jointed frame will be M minus 2j minus R. Number of members 1, 2, 3, 4, 5, 6, 7. minus 2j, it will be 1, 2, 3, 4, 5, that is 10. 10 minus r. What is r? R is 3, that is 7. So this is 0. So this structure is both externally and internally determinate. So basically we can conclude that this structure is a determinate structure. Similarly, this structure is also a determinate structure. Similarly, in this case, only one fixed end. So number of internal reaction here will be 3. 3 minus 3, no closed loop. So we are not concerned to see any internal indeterminacy. If there would have been a closed loop, then would have used this equation of DSI is equals to 3C, or for a plane frame, and 6C for a space frame. But there is no closed loop, hence we are not concerned with this equation. We will only see the external indeterminacy in this case, and that is 0. So this is also a determinate structure. Similarly, 2, 1, this is also a determinate structure. 3 minus 3, that will give the value 0. Okay, so these all are the examples of a determinate structure. Hope you have understand the concept of determinacy and indeterminacy in this cases, the several cases we have discussed. We'll now quickly jump to approach. Basically, approach is a bit different in case of beams, rigid frames, and pin jointed frames. Because in case of beam, basically usually axial deformation is neglected, where as in case of a pin jointed frame, it is not neglected because joints are not fixed. They are hinged or pinned. So extra displacement is allowed to those joints. So basically, approach will be a bit different. Not the concept will be the same, but the approach will be a bit different. If you understand the concept, the things will be like a butter for you. So uh, first of all, if we consider beam, then we know at free end number of unknown reaction is 0. Okay. Um, Roller 1, hinge 2, and fixed it is 3. Free end, there is no internal reaction. At roller, we have discussed it's 1, that is vertical. At hinge, it is 2, we know, 1 vertical and 1 rotational. And one vertical and 1 horizontal, it can rotate. But at fixed end, it is 1 horizontal, 1 vertical, and 1 rotation. This is basically calculating the degree of internal degree of static indeterminacy. In case of beam, here it is fixed 1, 2, 3. Here it is 2. So total degree of static indeterminacy here will be 5 minus 3. 3 is equilibrium condition. That is 2. Similarly, in this case, both end fixed. I have already discussed this example in the previous slide. Uh, at this end, there will be 1 vertical, 1 horizontal, and 1 rotational. Similarly, at this end, there will be 1 horizontal, 1 vertical, and 1 rotational. Total number of internal reaction is 6. 6 minus 3, that is 3. So this is an indeterminate structure to a degree of 3. These are some other examples. Uh, this is a continuous beam. This at this end, this is hinge. 1 horizontal, 1 vertical. Number of internal reaction at hinges 2. See, quickly let me write down one more time just to make you remember. If support is hinge, number of internal reaction will be 1 this and 1 this, because this can rotate, but this cannot move in a horizontal direction, and neither it can move in a vertical direction. So number of internal reaction will be 2. In case of roller support, see, roller support, it can move in a horizontal direction, but it cannot move in a vertical direction. So a vertical reaction will be produced. Similarly, it can rotate, so no rotational reaction will be there. So number of internal reaction will be 1 at fixed end. This, if this is a fixed end, then it cannot move in a vertical direction, so number of internal reaction will be there. Here it cannot move in a horizontal direction like this, neither it can rotate, so third is rotation. So number of internal reaction here will be 3. Free end, their internal reaction will be 0. So then we can quickly see, this is a hinge support, number of internal reaction will be 2. Similarly, at roller it will be 1, at roller it will be 1. So total is 4, 4 minus 3, that is 1. Similarly, in this case, this is a fixed end, 3, roller 1, this is again fixed, then total is 7, 7 minus 3, that is 4. So degree of static indeterminacy is 4. Now this is an interesting case. In this case, this is a fixed support, this is a roller support, and this is also a fixed support. So this at this end, the number of internal reaction is 4. At this end it is 1. At this end this is 3. The total is 7. Now 7 minus 3 will be 7 minus 3 will be the as per our approach till now. If we don't see this part, this is basically internal hinge. If internal hinge would have not been there, then the degree of static indeterminacy would have been 7 minus 3, that is 4. But in this case, two internal hinges are there. So each hinge release how many equilibrium conditions. This, please try to understand the concept. The number of equilibrium reaction released by a hinge, that is represented by RR, is equals to sigma m, or we can say, rather saying it m because it will give a confusion with number of members. Let us say it as capital minus 1. So capital M is the number of members connected with the hinge. Please understand, capital M is the number of members connected with the hinge. So in this case, number of members connected to this hinge will be 2, and similarly in this case it will be 2. So sigma means total number of such hinges. So for this case, m minus 1 will be 1, that is 2 minus 1, that is 1. In this case it will be 2 minus 1, that is 1. So total will be 2. So total 2 reactions will be released in this case. So degree of static indeterminacy becomes like this. If these two internal hinges would have not been here, the static indeterminacy would have been simply 7 minus 3. But due to presence of these two hinges, internal hinges, 2 reaction will be released. Hence it will go here minus 2. It will be 2. See, it is 2. So degree of static indeterminacy in case of a internal hinge will be seen and calculated by using this thing, number of reactions released by the hinge, that will depend simply upon the number of members connected with a internal hinge. Now I think this would have given you a clear concept of static determinacy, especially in case of internal hinge. Sometimes it becomes a bit confusing for students to understand this concept of internal hinge, but if you only remember the equation that I told you, that is number of internal reactions, number of reactions released by a hinge will be is equals to sigma m minus r, that is number of members connected to the hinge minus 1. Now this is that we have discussed in the previous slides also. The degree of static indeterminacy is consists of two parts, that is DSE and DSI. We have already discussed this thing. DSI is the degree of external indeterminacy, static indeterminacy, and DSI is the degree of internal static indeterminacy. See, this is a total static indeterminacy. This is external indeterminacy. This is the internal indeterminacy. Uh, this is DSI we have discussed. This is internal indeterminacy that is related to type of joint and frame. If a pin joint, there will be internal indeterminacy due to excessive members. We have already discussed the cases. DSI is related to internal configuration forces released due to hinges. We see that we have clearly seen the internal presence of internal hinge can create internal indeterminacy of a frame or a beam. So this also somewhere responsible for a structure becoming internally indeterminate. So this is what DSC in a quick summary we can say DSC is equals to R minus equilibrium condition, total number of reaction components to a given structure, that is R. In case of simply supported beam, R will be 3, that is one at hinge and one at roller. So for plane frame it is R minus 6. We have discussed in the second or third slide, I think. The same thing, just to give you a summary. Uh, so DSI, this is DSC external, and this is DSI internal, 3C for a plane frame, and DSI will be 6C for a space frame. These are number of closed loops. So number of closed loops. So okay, so I think this is enough for today's class, and we will be discussing about some more examples in case of a static indeterminacy in terms of calculating static indeterminacy in the forthcoming lectures. Um, See, the concept is very easy if you see if you just focus on the basics of and calculating the indeterminacy. If you understand, see, I'm not giving you certain formulas of calculating indeterminacy. No, there is no certain formula. Formulas are made with a concept. So you basically you need to understand the concept of indeterminacy. Basically, a structure might be externally indeterminate or internally indeterminate. So both for both condition, I clearly describe you how a structure becomes externally as well as internally indeterminate. So simply, if I take an example, uh, I said M is equals to the condition of internally indeterminate structure 2J minus 3. If this equation satisfies, then the equation is a determinate structure, internally determinate structure. Otherwise, it will be a indeterminate structure. So, where the formula comes, M is equal, that is DSE is equals to M minus 2J minus R. The number of members exceeding this part. So it will go to this side and it will give produce equation like this: M minus 2J minus 3. This is for pin jointed plane frame. Similarly, for a space frame, it will be M minus 3J minus 6. For rigid, it will be, it is given over here, it is 3C, and for it is 6C. So there is no formula, we just need to understand the concept and the things will become very easy. Hope this lecture would have given you a clear perspective of how to calculate the internal as well as external indeterminacy. Uh, in the upcoming lecture, we will be discussing more examples for developing a better understanding about this concept. Next lecture will basically focus on calculation of various more examples, calculation of static indeterminacy. In the upcoming lecture, we will also discuss how to calculate kinematic indeterminacy. Till then, thank you, class.